Hey everyone, welcome to another Clean Machine Live. My name is Geoff Palmer. I'm the CEO and founder of Clean Machine, and we are going to be talking omega-3s today. Specifically, a brand new study that just came out in August of 2024. So this is an interesting study, but before we get started, let's start with the disclaimer. This video is for informational and educational purposes only. It is not intended to diagnose, treat, cure, or prevent any disease. Okay, so omega-3s. Obviously, omega-3s, many omega-3s and omega-6s, most people don't know, are anti-inflammatory. Okay, so ALA, SDA, ETA, EPA, DPA, and DHA all have some anti-inflammatory effects. And omega-6, LA, GLA, and DGLA are all anti-inflammatory as well. So our body is converting all these omega-3 and omega-6 anti-inflammatory. Okay, anti-inflammatory. Let's dissect that word for a second. Anti, meaning stop, obviously. Inflammatory, inflame, like fire. Fire is a flame, right? Well, fire is the oxidation damage of wood. So when we see oxidation or damage, cellular damage happening, we call that inflammation. Just like that oxidation of wood is a flame, fire, we have that same thing going on a cellular level for us. Now, anti-inflammatories are reducing that inflammation. Okay, but how does omega-3s do that? All right, well, let's take a look. So we know that EPA, DHA, and ALA, as well as SDA, are all anti-inflammatory. So with that understanding, the researchers in this new study, I'll go ahead and put the study up on the screen, just published in August of 2024 in JAMA, the Journal of American Medical Association. So this was a big study published in the considered one of the top scientific journals. And it says omega-3 polyunsaturated fatty acids for secondary prevention of white matter lesions. You'll see that as WML within the study. So when you see WML, they're talking about white matter lesions. So we have gray brain matter and we have white matter too in our brains. When lesions are scar, kind of damaged tissue, basically, a lesion. And neuronal integrity breakdown. Okay, so the neuron has a structure to it, and its integrity is important because when its structure starts to break down, it can be dysfunctional or even worse, can be damaged and then have to be cleared or even be replaced with bad tissues. Okay, so that integrity is important, and the lesions or the scars or the wounds, basically, of our white matter are important. And these are markers for if that continues to progress, we can see dementia. Dementia is where our brains aren't functioning as well. It's because they've been damaged and they've scarred. So this is a randomized clinical trial, or an RCT. So it's a really nice study. Let's break down the study. So the objective of this study is to determine whether omega-3 treatment actually reduces white matter lesions, damage to the white matter of the brain, accumulation in older adults without dementia. So they didn't have dementia, and they weren't harboring any current major white matter lesions. And they had suboptimal omega-3 status. Okay. So what I like about this study, it was a 3-year study, and it used clinically significant dosages. They used high dose EPA and DHA, considered high dose. You can see as small as 50 to 250 milligrams of DHA. This is using a pretty significant amount. So this was what they consider high dose EPA and DHA. And they were really looking for a clinical effect because you're looking at needing to decrease inflammation, obviously in an older population. Let's take a look at the population of the study. It was 102 participants, so it's a good group. 62 women. Dementia happens a little bit more in women than men. We're not quite sure what that. There's some theories on that. May have to do with estrogen. And their mean age was 81 years of age. So they're already up in the years and stuff. But this is where you start to see the progression. Most people don't see the progression of dementia until the later years. So that is kind of a good time to do an interventional randomized controlled trial. Now, this is a quadruple blinded study. So no one knows what's going on, not the researchers, not the people taking it. So really nicely created study, and they were equally randomized into 51 per treatment group. Okay. Before I get into the results of this study, though, I want to point out something that's actually really important. It's going to be contextual to the rest of the research that we're going to be discussing. So, essential omega-3 ALA intake from foods. This is the average person consumes about 1.59 grams in females and over 2 grams in males of the ALA intake that we do is from ALA. The omega-3 intake, the essential omega-3 intake is from ALA. So most of us, while we're eating, about 70 to 90, and if you're vegan, up to 100% of our omega-3 is coming essentially in the ALA state. Now, this is not talking vegans or vegetarians here. We're talking about the average consumer. The average American is consuming almost most of their omega-3s as ALA, not fish oil. As you can see, the second sentence here, consumption of actually what they call preformed or dietary DHA and EPA from foods contributes to only a very small portion of the total daily intake of omega-3. So just to make that clear, this is from the NIH, the National Institutes of Health, their fact sheet. You can always see the links to the sources of anything that I quote down in the green section so that you can look that up yourself and read the research. Okay. All right. So let's get into the finding of the study. All right. So this is 3-year study, high dose omega-3 EPA and DHA from fish oil, very specifically. Okay. So we know it's 3-year study, high dose omega-3 EPA and DHA. All right. So here's the conclusions of the study. In this study, the omega-3 treatment was safe and well tolerated. Obviously, we know people can eat fish and it'd be well tolerated, so no surprise there, even though it was high dose, so we didn't see any problems there either. But they failed to reach any significant reduction in white matter lesions, that's damage to the brain, progression, and neuronal integrity breakdown. So no damage to the brain, no additional damage to the brain with the omega-3. So no difference. And the just to be referenced, it was compared to soybean oil. So fish oil didn't do any better than soybean oil, taking soybean oil. I mean, that's amazing to me. All this is, that soybean oil, that's gonna damage your brain and cause it. No, it performed about the same as omega-3 fish oil did for brain integrity. All right, so let's take a look at the chart here. So this is going to show you, right? Let me take down the caption first. Okay, so this is the findings from the study. Now, what's interesting in this study is you can see a trend line. So the trend line is, hey, wait a minute, these people are kind of getting worse. The number of white lesions or the brain damage is happening to increase over years. But you see the dark line there is omega-3s, fish oil, and really no difference than the pink line, which is the placebo, which is soybean oil. As a matter of fact, you can see soybean oil starts out a little worse and then gets a little better and then gets a little worse again. So you see basically a fluctuation line. The same we have with the omega-3s. It's basically the same trend line. So soybean oil was just as good at protecting the brain from white lesions, from dementia, basically. No different than soybean oil, fish oil. This is a pretty damning study for omega-3s, showing basically no benefits even when they consumed high-dose omega-3s for 3 years with high amounts, 2 to 3 times the normal amounts people take in fish oil for 3 years. And it didn't even make a difference comparing it to soybean oil. This is pretty embarrassing for the fish oil industry to have a study like this published. Now, some people might argue, hey, wait a minute, the trend line is showing right at the very tail end that soybean oil might be getting worse and fish oil might be getting better. Okay, so let's dive into that. Let me get to the off the screen. So let's dive into why is that. Okay, so when you go further into the study, the next thing they say after the conclusions, remember the conclusions were no difference, no benefit from taking fish oil at all. Now they did add in the conclusions, however, neuronal integrity breakdown was reduced, not lesions, just the neuronal integrity breakdown was reduced by omega-3 treatment only in ApoE4 to specifically carriers. Okay, what is ApoE? ApoE4. ApoE4 is what they call a genetic polymorphism. It's a gene difference. So a small percentage of the population have this gene alteration, this gene variation. And what happens when you have some, what they call SNPs, SNPs, these polymorphisms or these genetic differences, which only a small portion of the population has, can affect how well you produce the enzyme delta-6 desaturase. Okay, so let's dive into that. All right, so what is delta-6 desaturase? Let's take a look at that. Okay. All right, here you have on the screen delta-6 desaturase. All right, when you consume ALA up here at the top, let's see if I can do this way. All right, so this is alpha linoleic acid, the omega-3 that most people are consuming mostly. Remember, 70 to 90 and up to 100% in vegans of our omega-3s are coming in as alpha linoleic acid. Yeah, ALA. All right, then this enzyme is produced called delta-6 desaturase and knocks it down to or converts it into stearidonic acid or SDA. And then that is converted down to ETA and then EPA, DPA, and DHA. Let me take the caption off the screen so you can see that. Okay. Oops. All right, there we go. All right, and then DPA and then DHA here at the bottom. So this is a unidirectional conversion chart. This is how ALA is converted all the way down into DHA. But the rate limiting enzyme is right here, delta-6 desaturase or D6D. Okay, D6D is what's called the rate limiting enzyme. If we don't produce this one, the whole chain gets messed up, right? You don't convert ALA down to DHA, much better. All right, so for those who have this ApoE4, they may not be producing the first enzyme well, the delta-6 desaturase. This means that if you take a preformed, something that's already been converted like fish oil down to DHA and it's already converted for you, if you take that and you have this gene because it's not producing the conversion enzyme, then you're going to get more of the DHA. That's why you see this little bit of improvement. You can see it here at the bottom a little bit of improvement only in the integrity, the neuronal integrity in the brain cells. Not any lesions. It didn't stop any of the lesions from happening. It just maintained a little bit more integrity. So it's only with those that aren't producing this enzyme very well. Okay, so this is where it gets interesting. Let me go down. Can we bypass that delta 6 desaturase enzyme without having to take a preformed DHA down here and just start maybe with EPA or even stearidonic acid, SDA? And the answer is yes. Okay, so here is the conversion chart of just ALA. So ALA converts to SDA using that delta 6 desaturase enzyme. Now, what if we had a plant that actually produced a high amount of stearidonic acid? This one right here. Whoops. It's hard to do. This one right here, stearidonic acid. So stearidonic acid bypasses that enzyme, then it can flow down and keep going down the line and produce enough EPA and DHA to cause the anti-inflammation. So those with that genetic polymorphism, the few percent of the population that have that genetic polymorphism, could benefit by a plant that produces a lot of SDA. Well, I guess you're going to know because we provide it. This plant, ahiflower, is the richest source of omega-3 SDA of any plant in the world. All right, non-GMO plants. And that's why I brought it to market, and that's why it won the Nexty Award right there for the best supplement of the year in 2017. Okay, so let's talk how that affects things. All right, so this study was done on ahiflower compared directly to flax. All right, as you can see, the dotted line, ahiflower, resulted in a higher conversion in the plasma to EPA, higher conversion in the red blood cells, that's the erythrocytes. It can a higher conversion to EPA in the mononuclear cells, your immune cells, neutrophils. These are also immune cells. So all throughout the body, we're seeing much higher conversion of ALA, or in this case, in ahiflower, SDA, has a higher conversion rate to the EPA. Okay, so we're seeing that very clearly that SDA bypasses this delta 6 desaturase. All right, so let's keep going. So now we know you have a plant source that can bypass this rate limiting step that some of these people with this polymorphism, this genetic difference, who don't produce that enzyme sufficiently, may actually benefit from taking preformed DHA. But you don't need to take preformed DHA. You can take ahiflower instead. That's the cool part of this. All right. All right. So I sent this information over to my good friend, Dr. Tim Radek, and he is cited at the bottom here. I really encourage you to go onto YouTube and look up Dr. Tim Radek. He has done some amazing digging into this whole profile. Hope to be co-authoring a book with him on omega-3 nutrition. He has done some exceptional research, and he provided this quote for me: "No significant change in white matter lesion accumulation nor for neuron integrity breakdown, except for those with the ApoE E4 carriers." That's that genetic difference. They have a reduction in only neuronal integrity breakdown. He goes on to quote to say, "As a result, this may suggest limited benefit from exogenous," that's preformed, created outside of our body instead of our body making it endogenously. There's limited benefit to exogenous EPA and DHA, and also suggests that plasma status of these omega-3 fatty acids may not be a useful biomarker for brain health. All right. And when we look at that, you can see here from this study that carriers of the ApoE4 with the E4, the epsilon 4 allele, are vulnerable to a dietary deficiency in omega-3 fatty acids because they're not able to convert most of what they're intaking, the ALA, in the diet, whether you're vegan or not. Even meat eaters are getting the vast majority of their omega-3 on average from ALA because it's in greens and beans and nuts and seeds and fruit and vegetables. It's in all the plants, really, almost. There is omega-3 ALA in, it's ubiquitous through the plant kingdom. So everything plant that we're eating, we're pretty much, unless it's highly processed, we're pretty much, all whole food plants are pretty much giving you some sort of ALA. There's some exceptions, obviously, but vast majority of our omega-3 is coming to us in our food as ALA. So when you have this genetic, you are making that not available as much to putting out the fires. Okay. So let's take a look at something. This study is 2017 study, The Determinants of Fluid Intelligence in Healthy Aging. And it looked at omega-3 PUFAs and the status and the frontal cortex structure. And what they found was that better fluid intelligence was predicted with higher levels of SDA, ALA, and ETE, or commonly known as ETA, which is a metabolite of SDA. So let's take a look at that. Let me take this off the screen, and we're going to pull up the diagram so that you can see that once again. There are those three, ALA, SDA, and ETA. And these three were a predictor of fluid intelligence. So those with the highest amounts of these three, ALA, SDA, and ETA, actually had greater intelligence and greater preservation of gray brain matter. Now, that's pretty important to me. I want to have good intelligence as I age. I'm 61. And two, I want to preserve my gray brain matter so that I have it as I'm aging, because our brains tend to shrink over time with age. Now, I don't believe that's age. I believe that's diet and lifestyle factors that's causing a brain shrinkage because we're doing things to actually starve our brains. So it's actually shrinking, it's decreasing in size. And those with the highest intakes of these three. Now, this is interesting because if you consume EPA here or DHA, these are the two that are in fish oil, you're not getting any of these three, right? And these are the ones that are actually preserving gray brain matter. So this is a really interesting study, counterintuitive to what we were thinking about DHA being so important to the brain. No, let's dig further into that. And let's go ahead and pull this up on the screen. And as you can see, the black dots there are showing how much DHA is affecting BDNF, brain-derived neurotrophic factor. This is what actually stimulates the brain to heal and repair itself. Okay, the BDNF. And BDNF is increased when LPC DHA. Now, how does the body create LPC, or lysophosphatidylcholine-bound DHA? Okay, so you see the red dots? That's LPC DHA. LPC DHA is made in the liver, and it can be made in the liver from ALA. As a matter of fact, that's why we don't see ALA being converted in the bloodstream, because it goes directly to the liver where it can be converted into LPC DHA, and that LPC acts as a shuttle to cross the blood-brain barrier so it can get into the brain. Okay, so this is really cool. So you see the black dots on the bottom, very little brain-derived, almost no brain-derived neurotropic factors going on in the brain. But you see the LPC, the red dots, that's from ALA converted in the liver and then sent to the brain. Much greater stimulation. So you see that both in plasma BDNF, an increase in BDNF in both the cortex and the hippocampus, different sections of the brain. Okay. What else increases BDNF in the brain? So there are really basically two omegas that increase BDNF. That's what gives our brain the ability to process better. BDNF stimulates growth, stimulates repair, stimulates the nerves to function at a higher level. So you want that higher level of BDNF. Well, you look at here, and this is before and after in the hippocampus and the cortex of ALA. That's right, ALA from plants. ALA is only made by plants. Animals don't make ALA. ALA actually enters the brain directly. So it's not only DHA. DHA actually has to be converted into LPC DHA in order to get into the brain. As you can see, the triglyceride form in fish or in algae does not get into the brain. It has to be converted at a later time. Whereas ALA goes directly to the liver and is being converted to LPC DHA. But the other factor is ALA is actually increasing the amount of BDNF in the brain. So both DHA and ALA can increase BDNF in the brain to heal and repair the brain. So high intakes of ALA will also help the brain. This may be another confounding factor. Now, they didn't measure this in the 2024 study, but there may be one other factor. It's not just BDNF. Let's go back to the research. And a very interesting study. This one also just came out in August of this year. This 2024 study, anti-inflammatory diet and dementia in older adults with cardiometabolic diseases. Cardiometabolic diseases are mostly diabetes, high blood pressure, these things. Okay, so it's called the UK Biobank study. The 84,000 dementia-free adults over 60, so they were already at 60, did not have dementia, 84,000, huge study. And those that followed, they followed those for 12 years, one group on an anti-inflammatory diet high in plants. So plants have antioxidants and polyphenols and all these things that reduce inflammation in the body. And then they standard American diet, processed foods, animal foods, which are pro-inflammatory. And those on the anti-inflammatory diet had a 31% lower risk for dementia. Real clear here. All right, it's not just DHA because we're talking inflammation. So when you're talking inflammation, EPA and DHA work as anti-inflammatories, but so do other plant nutrients like polyphenols, like antioxidants. These reduce that. Like fiber, when you consume fiber, fiber converts into short-chain fatty acids. They themselves are anti-inflammatory. It's amazing how powerfully anti-inflammatory is. They boost our immune system to allow our immune system to function better too. All of these things reduce the inflammation. So, you know, I want to say, wait a minute, let me remove this, that we are so focused on putting out the fire, anti-inflammatory agents like DHA, ALA, stuff like that, and not looking at what's causing the fire. You know, first, instead of just saying, hey, we need more water to put out more fire, let's take a look at what's causing the fire and turn off that. If there's a fountain there gushing gasoline in the fire, you want to turn that off first, or you're just going to keep putting water on a fire that will never go out. We're looking at it from the wrong end of the problem here, I think. We're looking at it from how do we put out the inflammation so it doesn't cause or slows down the damage. And we see in this study, the 2024 study, that even DHA, as anti-inflammatory as it is, didn't reduce the inflammatory, damage being done in the brain, did not reduce it compared to soybean oil. My God, it's like most people would consider soybean oil pro-inflammatory. when DHA is not any better than a pro-inflammatory oil for reducing inflammation in the brain, we're looking at the wrong problem. We need to stop saying, hey, wait a minute, let's just pour more anti-inflammatories in there. Well, if it's not making a difference here, and it's clearly not, you can see it right on the screen. That's compared to soybean oil. That's DHA, high dose, over 3 years. No difference. All right. So what we're seeing here is we're looking at the wrong end of the problem. We should be more concerned about reducing the cause of the inflammation, which is dietary and lifestyle things. Obviously, the clear ones are don't smoke and don't drink alcohol, but looking at pro-inflammatory foods like meat, like dairy, like eggs. The animal proteins are almost all pro-inflammatory. And almost all of the whole food plants are not only anti-inflammatory, they're significantly anti-inflammatory. We saw that in the arterial stiffness study. I don't have that one up, but I'll just explain it to you. They said their proposal was, hey, wait a minute, DHA is shown to improve cardiovascular health, the vascularization health, right? And okay, well, if that's the case, but they were only looking at it compared to a meat-based diet. A meat-based diet was doing a lot of damage. Those just consuming a higher DHA from fish oil had less damage, but less damage compared to what? Compared to the worst, which is a meat-based diet. So they said, all right, since vegans have little or no intake of DHA unless they're supplementing with algae oil, all right, let's take vegans. And the vast majority of them were not supplementing with DHA, and their DHA was in fact lower. And their arterial health was lower. Their LDL cholesterol was lower. Their triglycerides were lower. The damage to the arteries was lower. Their blood pressure was lower. All of the factors for health, they even said at the very bottom of the study, this actually shows that vegans had a markedly improved less aging of their arteries than did those consuming the highest amounts of EPA and DHA from fish oil. So even the EPA and DHA, yes, it was better than a meat-based diet, but not as good as the high plant or a plant-exclusive diet. That's the powerful inflammation. One, you take away the source of the inflammation. Okay, one of the most inflammatory substances in the human body is arachidonic acid. It is pro-inflammatory, except people got this assumption that omega-6s cause the production of arachidonic acid, since it's omega-6. That's not true. You can take all the omega-6 you want. They actually increase the amount of omega-6 by 20-fold, and arachidonic acid levels in the blood did not change. It's because the body won't convert omega-6s to arachidonic acid unless it needs it. So the plasma amount, they dropped it 9 times lower, and it didn't change arachidonic acid because the body's pooling omega-6s and can convert it all when it needs to. So they raised the intake of omega-6s 20-fold, 20 times as much, and no change in arachidonic acid. The body tightly regulates and controls arachidonic acid so it does not create inflammatory states. So how does arachidonic acid increase and start causing inflammation? The only place you can get arachidonic acid in the diet is from animals, because plants do not and cannot make arachidonic acid. Only animals make arachidonic acid. Humans do it. We make our own for pro-inflammation to help heal and repair. Even our brain uses a little bit of arachidonic acid. But what you don't want is dietary arachidonic acid. This is called free arachidonic acid. This only gets into our bloodstream through diet by eating animal products. So the only way you can create a pro-inflammatory arachidonic response is by eating animal products. Plants do not and cannot make arachidonic acid. It's impossible. So we're seeing once again, the cause of inflammation is animal products, and the reduction of inflammation is vastly, majorly from plant products. Real clear, if we want to decrease, and I'll put this back up on the screen because this is important. If you want to decrease 31% lower risk for dementia by those eating a high anti-inflammatory, a high rich in polyphenols, fiber, and antioxidants, all from plants. Polyphenols, fiber, only come from plants. I take that back. Animals who eat polyphenols, like herbivorous animals, will have some of those polyphenols in their tissues, but only a fraction of what you find in whole plant foods. So if you really want to get a strong dose of it, you're going to have to eat plants. If you want fiber to produce the short chain fatty acids, you're going to need to eat plants. There's only one way to get this. Plants are the only ones that make polyphenols. Plants are the only ones that make fiber. This is where we're going to get this. Plants are also high in water, higher in micronutrients too as well. These help detoxify the body and reduce that. But it's not just that study, even though that is a brand new study. Several other cohort studies also suggest lower dementia risk with anti-inflammation diets, highlighting this as a significant modifiable lifestyle factor. This means, thank you, Dr. Tim Radek, for supplying this. Those are the additional studies down there. The Bransby study from 2024, I just went over with you, but the other studies, the Hayden study, the Charissa study, and the Shinto study from 2023. So all fairly recent studies are all showing the same thing. Reduce the pro-inflammatory. Remember, arachidonic acid is found in all animal flesh. It's also found in other animal products too as well, including fish. So your consumption of arachidonic acid is by nature pro-inflammatory. Plants don't make arachidonic acid. It's impossible. No matter how much omega-6 from plants that you intake, it will not increase pro-inflammatory arachidonic acid because it's tightly controlled endogenously in our body. Our body doesn't make something that damages itself. It just doesn't do that unless we've already screwed it up and it's just trying to protect itself from dying. So it's real clear here what's causing the inflammation. It's real clear by this original study that that there is no effect. This 2024 study, 3 years, high dose of omega-3 from fish oil did not improve the risk of dementia at all. Zero. The only place that improved that was by those who had the ApoE4 gene, and that's because they're not producing the delta-6 desaturase and converting that ALA down into SDA, EPA, and DHA. Ahi flour does that. Ahi flour is the richest source of SDA of any plant on the planet. That's why it won the Nexty Award for Best Supplement of the Year. It's why I chose it to be the only omega supplement I sell. It's because it is the best. And it is the best for everyone, even those with the polymorphisms that make them not produce sufficient amounts of delta-6 desaturase, which can lead to these problems such as dementia. I know Dr. Joel Fuhrman has talked about his fears, even Dr. Clapper has, and more recently, I saw a post from Dr. I'm blanking on his name. A lot of good vegan doctors out there are taking omega-3s, preformed DHA from algae because they fear this process. What we're seeing, I believe, what we're seeing is just vegans who have that ApoE4 not consuming a source of omega-3s from plants that bypasses that first step. if you want to understand why I will never, ever take DHA, because it increases LDL cholesterol, which can put you at risk for cardiovascular disease states. It increases atrial fibrillation up to 49%. Those with atrial fib or AFib have a 63% higher risk of dying from a heart attack. I would never put that stuff in my body. Why would I do that when I have a different plant source that doesn't do that? I want my body to decide when and where and how much DHA it needs and convert it. But I need to give it something, a plant source that allows that precursor, ALA and SDA, to convert and allow my body to make that decision on how much, not force DHA into my bloodstream that can cause atrial fibrillation, resulting in a heart attack that can not even result in benefits to the brain, which is why all this fear from the doctors, oh, you got to take omega-3 algae DHA because it reduces the risk of dementia. Well, this study shows that's not even true. It's just because the ApoE4 gene, that's the cases where it starts to be effective, and that's what makes ahi flour so much better than flax and chia, where most people are getting their omega-3s in the plant-based community. This is why I am so passionate about this, because I think people are putting themselves unnecessarily at risk for increasing their cardiovascular, major adverse cardiovascular events, or MACE, just by being scared that they're not getting enough for their brain. And what I want to say is that's just not true. This is another study that shows that pretty unequivocally, that DHA and EPA were no better than soybean oil at preventing the incline of increasing dementia. None, not better at all. And that's 3 years. It's not just looking at it as short term. This is long term, and it was a decent sized study too as well. Look, with every study, there's flaws to it. We need more research for sure, but this is something to keep looking at. But what we're seeing over and over again is this is not the case. And what we are looking at is the reasons for the difference is because people are consuming DHA, and DHA can be a problem. DHA blocks ALA from being converted. DHA blocks EPA from being converted. DHA blunts the positive cardiovascular benefits of EPA. I would not put DHA in my body. And as a vegan, I naturally don't put any DHA in my body because it's not in my food. And, you know, to say that we need DHA is to say that a vegan diet is wrong, and it's not. It's just that we don't understand what's going on. And now we have research that clearly does show plants had it right all the time. But specific plants can help specific people with genetic differences. So those with genetic differences, and you know, you can spend your money doing some very expensive genetic testing, or you can just take one that you know will cover all your bases. That's why I did this, so that anyone who is consuming a plant-based diet and is concerned about their brain health can make sure that they're getting enough of the EPA and DHA to supply the brain. And obviously, we as whole food plant-based vegans, not junk food vegans. Junk food vegans are causing just as much, can be causing just as much inflammation in the body as those consuming meat. Not quite, but close. And so what I'm talking about is whole food plant-based folks. They're eating a strictly vegan diet, meaning no animal products whatsoever. You can get your omega-3s, even if you have genetic differences, by consuming a source of omegas that is high in SDA and bypasses that first step. I know this was a lot of science and it seems really complex, but it's not. It's really simple and it's intuitive. Our body is designed to consume plants. It has a very specific pathway of converting each step so that it can regulate how much of each form, ALA, SDA, ETA, EPA, DPA, and DHA. it has enzymes in between those, so it can turn on and off those enzymes and regulate exactly how much we do. By putting DHA in there at the bottom, you just override the whole system. You override the wisdom of the body that is saying, wait a minute, that's too much DHA. That's going to cause heart problems. Did you know our heart muscle does not even have the ability to convert ALA to DHA? That's to keep DHA away from the heart muscle. And here we are dumping DHA in this preformed state into our bloodstream, spiking it and causing atrial fibrillation. The way it does that is the DHA causes what's called permeability. It's the body's ability to take in different fluids, and it makes the structure of the heart, which needs to be rigid, so it pump, pump, has a nice rhythmic bar to it. If you make it less rigid by opening up the gates and allowing more fluid in there, now it's like a waterbed, and now you have irregular heartbeat. And that irregular heartbeat gives you a 63% higher risk for a heart attack. Why would you take that DHA and stick it into your bloodstream and put your heart at risk for failing? That's just crazy to me. And I really want to get this out because I'm seeing so many vegans and those on a plant-based diet taking fish oil or taking algae oil if they're vegan and don't want to do that, and they're putting this preformed DHA into their bloodstream. Exactly what our body does not want to happen because of its effect on our LDL cholesterol, on its negative effect in blocking our EPA. EPA actually improves our cardiovascular health, and then you pump DHA in there and it blunts it or blocks it completely, actually increasing your risk for major adverse cardio events. DHA increasing your risk for a heart attack. That's exactly what the MACE study is. Look it up. Don't take my word for it. The research is out there. DHA can be damaging to your heart. That's why our body has it at the very bottom of the conversion chart, so it can make sure it doesn't overproduce it. It can turn off any of those enzymes before turning to DHA, so it can tightly regulate DHA, tightly regulate the amount. Only bring it out when and where exactly it's needed, instead of you just dumping a whole bunch of it into your bloodstream and going to the heart, sending us into AFib, and then causing higher cholesterol, LDL cholesterol. That's just silly. Well, all we're doing is replicating the damage done when those are eating on an animal-based diet. I just don't get this. I know this is heavy, deep science and stuff like this, and I'm sorry for going so deep on this, but I think you have to understand what the mechanisms of action, because if you just look at ALA doesn't convert to DHA in the bloodstream, well, then you'll make some bad assumptions. When you realize, oh no, ALA doesn't want to convert. Our body does not want to convert ALA to DHA in the bloodstream so that it doesn't cause AFib. That's why you don't see ALA converting to DHA in the bloodstream. Instead, the body takes ALA and converts it safely in the liver. And it converts it to the right form, LPC DHA. Now, when it's bound to a lysophosphatidylcholine molecule, it's not going to affect the heart. Now it's safe DHA, and then it can be taken to the brain, and that LPC molecule helps it cross the blood-brain barrier and get into the brain. That's the exact form that the body mostly uses for brain health. ALA is the proper pathway. We had it all wrong. This blood test, this omega-3 blood test, saying that, oh, geez, ALA doesn't convert to DHA in the liver. Awesome. That's exactly what your body is supposed to do. Don't convert it in the bloodstream. You do not want it converted in the bloodstream. You want it converted in the liver so it's safely out of the bloodstream and not negatively affecting the heart. That's why you see ALA converting in large amounts to EPA, because it helps the cardiovascular system. It improves cardiovascular health. If you look at all of the EPA studies, all the ALA studies, they both say they both increase and improve cardiovascular health. When you look at the DHA only studies, you see it lowers or prevents the benefits of ALA and EPA. It blocks EPA production. It blocks ALA conversion. It increases LDL cholesterol. It increases your risk for afibrillation. That is why the body does not want to convert ALA in the bloodstream. So this observational study that ALA doesn't convert to DHA in the blood, so it must not be beneficial for us. No, we didn't look at the whole pathway. When you look at the whole pathway, you see really clearly why the body does not want to convert ALA to DHA in the blood. It does so safely in the brain directly. ALA can go right to the brain, go into the brain, and be converted in the brain safely away from the heart, or it can go to the liver, be attached to LPC. Now it's safe and won't negatively affect the heart and could go into the brain. Instead, we're taking DHA from animals or fish and dumping it into our bloodstream, negatively affecting our heart and our cardiovascular system. I hope I'm clear enough on this, because we have this so wrong. This information is so backwards that if you do not understand the complete process, the complete metabolic pathway, and the reasons our body chooses this pathway, has this long step-by-step conversion basis. Once you see all that, the picture becomes obviously clear that the plants have it right, that we should be consuming ALA and then let our body decide exactly the right place to do it for our age, for our gender, for our health conditions, and in the tissues where it needs it, the brain where it needs it, not the heart where it doesn't need it. By sticking DHA into our bloodstream, you are getting it to the heart where it can do damage. This is the problem. This is the problem. All of this is showing us that human beings should not be consuming animal products because they almost all have preformed DHA in it. This is a powerful example of why our body is designed to consume plants. Now, can we throw some animals in there on occasion and it not really affect us all that much? Yeah, probably so, just like our ancestors did. Now that we're consuming animals on a regular basis, we're seeing all these disease states because it's something that goes against our natural physiology. Our physiology is designed to convert ALA to plants. Carnivores don't even have the first 3 steps of conversion. They don't, because they're eating animals, which only have EPA and DHA. So their body adjusted by only needing EPA and DHA. Ours doesn't. All herbivore animals convert ALA all the way down, just like human beings do. The physiology is identical, and it is totally different from any carnivore. They don't even have the first 3 steps. They don't consume them. They don't make them. It's impossible. They just lost those first 3 steps of ALA, SDA, and ETA. They start with EPA. So for us, our only essential omega-3 is ALA. For carnivores, the only essential omega-3 is EPA. It starts lower. This is the difference. We've got to understand our physiology to better understand what we should be putting in our mouths. We can choose to put anything in our mouths that we want to, but is that the best thing to do for our overall health? I hope this information helps. If you do, give it a thumbs up, give it a like. Please pass this information on, because I think a lot of people are unknowingly harming themselves thinking they're doing something good, or based on fear that somehow they're not going to get enough of the nutrients. Yes, those with ApoE, E4, genetic variations, or FADS2 variations don't produce the rate limiting step. That's why I sell and produce ahi flour, because it overcomes that. It has SDA, which bypasses that rate limiting step and makes it available for all people, regardless of genetic information. Obviously, consult with your doctor. If you have any other specific things that may cause you to require DHA, for God's sakes, take that, give your body what it needs. But for the vast majority of people, this is going to cover the bases as long as you're taking sufficient amounts. That's why I take it every day. That's why I take ahi flower every day. I want to protect my brain. I want to not damage and put my heart at risk. I want to improve my cardiovascular health. That's why I work out every day. And, well, not every day, but most of the days. And why I encourage other people to do the same. I want you to live the best possible life you can, the healthiest, the fittest, the most optimal health, and keep your brain and your gray matter preserved by consuming high amounts of ALA, SDA, and ETA, which you can get from ahi flower. Thanks for watching. We'll be back next week. I'm going to keep digging up these studies and keep sending them out, because we really need to change and rewrite the books on omega-3. We have it wrong.